Welcome back. Our previous video introduced extreme value theory and compared it with the central limit theorem. And in this video, I wanted to use Monte Carlo simulation to showcase the properties of the central limit theorem, as well as the cases when the maximum order statistic would give rise to the Gumbel distribution or the Fréchet distribution. And my hope is that going through this Monte Carlo will give you additional intuition about what's going on with these different theorems. And briefly, the central limit theorem is going to give us the limiting distribution of the sample average or a similar statistic. And the way we're going to set this up is we're going to have samples that are 100 observations in size, and we're going to replicate those 1 million times. And the underlying distribution is going to be exponential, and we're going to compute the average of each 100 observation sample, so that we then have a 1 million length series of sample averages. And then we can look at what's the distribution of that compared to what would be the theoretical distribution according to the central limit theorem. And then on the extreme value side of things, we'll continue to assume that x is distributed exponential. And then we'll show that if we instead take the max of each of those 100 observation samples, that the distribution of the resulting 1 million maxes converges to a Gumbel distribution. And then to show the Fréchet convergence, we'll instead change the distribution to be Pareto instead of exponential, because the exponential has thin tails and the Pareto has thick tails. And we'll show that that results in the Fréchet distribution. And then we'll also show that the minimum of an exponential converges to an exponential. And with the minimum extreme values, that might differ depending on what the parent distribution is. We're not really going to go over Weibel because Weibel is not really used that much in economics, not because I have anything against it, but if you're really curious about this, you can use the code that I'm going to put a link to in the description, and you can modify that, and I'm sure that you'll be able to replicate the Weibel as the limiting distribution if we say that it's a uniform parent distribution, for example. Let's move into the code now, and as usual, we'll be working in Julia, and if you're in VS Code doing this, you should install the Julia extension, because that's going to allow you to preview the plots when we do some histogram and curve plots. What packages do we need to do this? We basically just need packages around random sampling. So the random package, the statistics package, the distributions package, and then a couple of plots packages. And then Julia is not as friendly in terms of creating plots and exporting plots as, say, R's ggplot. So there's a bit of code to initialize the style of things, but this is just boilerplate code. And then in this section, we're setting up the sample size of each draw, as well as the total number of replications. And for the Fréchet case, we need to actually have quite a bit larger of a sample because the tail behavior is so thick with the underlying distribution, the Pareto distribution. And so we actually need to have about 100 times the sample size to be able to pick up the tail behavior appropriately when the underlying distribution is Pareto. Okay, so the central limit theorem is very easy. We use the distributions package to set our distribution as exponential, and then we just sample from this. So I say rand of whatever this distribution is for each sample size, and I'm going to do that 1 million times. So this is going to give me an object with 1 million elements, each of which is the sample average of a 100 observation draw from this population distribution. And then I can get the mean of those averages and the standard deviation of those averages. And then I can plot that ensuing or that implied normal distribution against the histograms of the actual million length numbers that I had generated. So that's going to be the first plot. And then the second plot, instead of taking the mean, I'm going to take the max, and then I'm going to make some normalizations with the Gumbel. And then I'm going to do the same thing. I'm going to plot the density of that implied Gumbel against the histogram of that million length set of maximums. And then we're going to do the same thing to generate the Fréchet distribution. We just have to use a much larger sample size, and we need to use the Pareto, but we're still going to take the maximum. And then we do have to normalize in a special way and also throw out some of the extreme upper tail. just to get our plot to match the way that we need it to. This is a situation where the theory is fine, but then it gets a little messy if you actually try to do it numerically. And then we can just do the same thing where we plot that histogram where we've thrown out the extreme upper tails just so that things scale appropriately when we graph it against the implied Fréchet distribution density. And then we can do the same thing as we originally did, except we take the minimum instead of the average, and then show that that thing is actually an exponential distribution. So that's what we'll be doing here. Now that the code's all set up, and assuming that you have these packages installed, we can just hit this play button, run in REPL, and wait for it to execute. On my machine, it's going to take about 20 to 30 seconds, and most of that's going to come with the Pareto step because we had to have such a larger sample size per draw. So that finished, and one thing that you'll notice is that it created this plots window. This is a feature of the Julia extension in VS Code, and I can click over here and I can also see a preview of the plots. So I had already run this code once before starting this video, and so I have basically 8 plots, which is just 2 copies of each of the 4 plots that we wanted to create. And we can see the central limit theorem in action, that empirical histogram distribution looks a lot like the theoretical normal distribution. And same thing for the Gumbel. We're getting that the maximum of those exponentials is distributed Gumbel. And then we also get the Fréchet from those Pareto distributions. And then finally, the minimum of exponentials we also find to be exponential. So we've verified using Monte Carlo simulation the properties of the central limit theorem and the Fisher-Tippett-Gnedenko theorem. And in the next video, I'd like to discuss the Fréchet distribution more specifically, talk about its unique properties and how they might be useful in economic modeling. And then the video after that will be the last in this mini-series where we'll go through a famous trade model that uses the Fréchet distribution quite extensively and show how that helps with the tractability of the model. I hope that you've built your intuition with this video, and I hope to see you in the next one.